Hi. Hi. You. No. Does it work? It does work. Okay. I thought my mic wasn't working. Wasn't like actually connected. But it is. And okay, let's byte the bytecode. Let's the variables, let's do functions. But first we'll have to do type resolution. Could do casting today, I guess, too. We'll definitely need to add implicit casting for function args. Something that I don't do yet, but we also don't have function args. Okay. So we want to be able to run all this code today, at least. Maybe we also do functions. But I also want to do globals the right way, so I don't think I'll do hash tables today, because that's probably its own stream. Yeah, let's do type resolution as its own step. So basically what this is like we just do void resolve type, resolve expression type, expression, right? We'll grab the type scope for that. I think I'll actually make its own file for that. Resolver. We don't do classes. Okay, let's move that to Kairos and let's move that to SRC. Like this, okay. I don't see a resolver.h. Where is it? Oh, it's here. Okay. Just say resolve AST, Kairos, AST. Right, and then this actually will be here. I think I'll resolve the AST here. Resolve AST. Right. I'll have to include the resolver. Don't like calling all of those action verbers, but we'll think about them later. Resolve AST. But I don't know about that though. So that means we have to write yet another error handling. Huh. Maybe we do that in compiler then. That would make sense, I think. Yeah, that does make sense. I like that idea. So I'll remove those two files. We'll delete them permanently. We'll add it to compiler as here. We'll say resolve AST, right? Also doesn't really make much sense because I would have to pass the program here. Let's do it like this. Let's do it in the parser, right? Have resolve expression, resolve statement. Okay. Resolve st, right? Huh. So the scope arena would be here, right? This should also be statement, I think. Statement needs to be the first arg. Expression the same. But then do we need something more is the question. Resolve, so this is free arena, scope arena, right? Just say for each statement, right? STMT of IST statements first. STMT equals STMT link max, and then we resolve that statement, right? Statement STMT. I actually also want pre-resolution, I guess. Pre-resolve statement. And this one is not recursive, right? Hmm. I don't know, because pre-resolution... Like, pre-resolution is the whole reason we're doing it. This is so complicated. Jesus Christ. Maybe we just can't do it. That's so stupid though. How do I do this? So you can't resolve. So what I wanted to do is first like resolve all the global types, and then resolve all the other things. It's not entirely possible. Don't think. One sec. Yeah, I have no fucking idea. It's the thing that requires us to like add more things to the language, right? More assertions, basically. Like, and no, that doesn't really make sense because if I could, I could make just constants be like bound, but then I also want like, I mean, I can accept that we only have constant functions at the global scope, but I can't really accept we don't have non-constant globals like this, right? I want this to be possible. Also, I think I need those files. What is the shortcut? It's Control Shift A. Does it work? Oh, it does. I'll say AI resolver again. I'll say Jesus. This UX experience so bad. Resolver dot H. Why? Why aren't they both here? Hmm. I'm so tired of like having like 5 different fucking structs for all the compilation. It's like I feel like we should just merge what we can. So have, I don't know, have them as one struct or something. It's not like you will be just doing AST ever. It's like you always also compile it. I don't know. Okay, let's grab all this like type stuff. This too. Let's move that to the resolver. I hope I'm not shooting myself in the foot with all those changes here. Hmm. This is a disaster. You can't fucking. How does JI do this? I wonder. Because they have light bound globals. But here, like, I can't even parse function calls if I don't know the function type. So that's a disaster. Maybe I'm wrong. Let's remove result type from here. Let's just do ordinary resolution first, and then we'll worry about other things. Let's remove this from everywhere. Not make type scopes. I wish I kinda knew that, like if I knew more about how to do all of this bytecode stuff and like other things, I would have not really made the same decisions at all. Let's remove this too. We never want to deal with that. Don't deal with that, don't deal with that. No with that, no with that. Don't deal with that at all. Oh, I guess function calls just work now. Suddenly. Here, yeah, we don't do param checking at all. Just add args as they are. Do that in the resolver. Hmm. I just did that stupid yet another type. I technically don't have a compiler, right? Full head errors is what we always need, and then we need an arena. It's called arena. Start with that. Have a resolver. Replace all of the parser stuff with just resolver. Okay. Now we'll need a static void resolver, error, resolver, resolver, or error. Also pass it a token. And we'll basically use the same thing from compiler. I think there's one awkward thing where, like, yeah, a Kairos program has had errors. That's the thing. It's silly. Silly as fuck. Probably one who had a compiler struct XD. But yeah, there's one thing I want to copy, and it's this function. So basically the same thing here. Though I don't think we have to actually break out of this for this one. Okay, and here we would just say think about that in a sec. Ahoy now, P. What's up? I'm doing some painful refactors that I don't know where they will actually take me. So it's all pretty interesting, I guess. So many stupid times. Token. Should probably be passing token as the last thing, maybe. I don't know. Token. Timestamp. Token. Okay. Yeah, it's good. Write your own code. It's always really good. Expression type. Holy fuck, how did that happen? Oh no, never mind. But those three files were indented. Just don't have the fucking arrow. XD. It's funny. Funny feature. I don't know why would anyone use it. So they still have errors? push expression. Right, yeah, we don't need to type here. Maybe we do. Yeah, right. This should still work. Okay. And then now in resolver we can just determine all the result types. Let's just resolve all statements here. We'll say switch statement type. Maybe I just have all the statements there. Right. Doesn't sound like a bad idea. And the default would just be default. Resolver error. Resolver. Statement token. Unsupported statement type. Okay, we'll do the same thing. So let's also just do if no statement and return. Right. Let's do the same thing for expressions now. Yeah, oh my god. Let's just replace this with expression. Just like that. Okay, and now for scopes, we just resolve expression type resolver statement scope statement. Oh yeah, so this is a loop. So for statement scope. Oh no, select statement. STMT equals statement. Scope statements first, right? STMT equals STMT. Length next, right? We'll do that. Also, oh yeah, this is actually resolve statement, right? Now if we'll resolve statement scope, statement if then and else, right? Then we'll also evaluate the expression type. Right. We'll do the same thing for the while loop. Return signal, I think. I guess this is just like a return signal value, right? This is what we evaluate. Identifier of, we evaluate the identifier of value. An expression statement, we evaluate, we resolve the expression statement expression, right? So this is just for chaining the resolutions. Okay, and now in here, I have to do a similar loop for the print. Say expression, print, expressions. Like this, and we'll just resolve their types. Resolver, expression, type, scope. So first, let's just channel the recursive calls for resolutions. Expression. Also, this post is no longer applied. We can just remove. Identifier. Let's resolve it. Oh, yeah, here we just actually, we don't chain anything in this. For function, expression, function, expression, function, scope, right? So what do we need to resolve? This is a statement. Do they have something to resolve? No. Okay. So function, all it has to resolve is the scope. Okay. Function call doesn't have anything. Oh no, it has to resolve all its args. Arg. Say function call args first, like this. The argument. Arg, right? Okay, and it'll say to do type check against params. Okay. So here we'll say expression result type equals expression value type, like this. For identifiers, we'll have to use the type scope, right? Okay. recompile. Don't. We have to pre-declare stuff. Also, this has to be in resolver. We'll make resolve AST just returnable. And we'll return if we didn't have errors, right? If resolver had errors, is what we return. And parser, we'll say this. If parser didn't have errors, and we are able to resolve the AST, right? Then we return it. Otherwise, we free the AST and we return nothing. Okay. That works. So what I need, by the way, is I need to change the fucking... Yeah, so what I need to do in the parser is make function calls. Function call. Instead of name, it should take an expression. What it will do now is it will have a thing here, expression, read call expression, parser. We'll have we'll just have expression left, right? Left equals read primary parser. And a while lexer accept token parser. Lexer lex token type. Let's open parent ring. So while we accepted, we'll always return left, but while we accepted, we want to parse calls like this. Here. Okay. Okay, now the expression's just whatever left was, right? And the token is, let's say, left token. Or maybe we just say parser. Parser, lexer, current. Should work, right? Just point to the open parent on any kind of error. Function call expression left, expression, read expression. Okay, that's all good. This is how we parse the function call. And then what we do is we say left equals function call. Yeah, because we chain them like this. So if we have a function that returns a function, so something, it calls a function, returns a function, and we call it like this, right? If we would be chaining, so something returns a function, and then we call it, and that something also returns a function, and we call it again, right? That's how we would do it. So now read expression would read read call expression like this. Right? Yeah. So this is like a unary expression, but it's left to right instead of right to left. Yes. Okay. So this should do it, I think. Um. Okay. So now if I say something 1, 2, 3. Well, ignore resolver and compiler for now. I just want to see what it actually is. It seems like the function call value is something and the argument is 1, 2, 3. So this is all correct. This is actually one thing that we had here. It's make scoping and count now. Make sure now. Okay, so this is what it is. Really, no. This is make function call work on a literal value instead of name. Oh, this is actually fully done, I think. Or is it? So wait, let's make it like so. X, make function calls work on a value, not a name, right? And now this thing we can do in a sec. Okay. Another thing that we will do immediately is make functions and variables use the same storage. Those are just things that are now really easy to work on, since I'm also just reworking the system around it, so it's just something that there's no reason for me to write the code for the old style if we use the new style. Yeah, let's look into the function later rule. So we have something that's called assign expression, right? This is kind of redundant. All we need is this. And this should just be... It just should be a parse primary kind of thing. Right? Or no? Or is that just... No, this is an expression for sure. Maybe all I need to do is like do it here, right? And read the expression, right? And then assign expression we can just completely wipe and have it here. A value equals read expression, and then we expect a semicolon like this, right? Same thing here, read expression. Here we also read expression, and that gives us the control to say assign expression assignment, expression declaration, right? This would be constant declaration. Right, gives us some more room to customize the error messages, right? It's funny that this even compiles. Seems like they left this something call, right? And that's why I tried to pop, I tried to pop something I shouldn't even have. I wonder how does it even work? Oh yeah, because wait, really? It's like it evaluated it 1, 2, 3. This thing, the argument. But I don't compile function calls at all, so that's interesting. That's basically unexpected right now. Scout expression statement. Wait 1 sec. Oh, this is an expression statement. Right. Of kind function call, right? Value is something. It's really fucking interesting that it can't even refer to that because. So I guess what I should do is, right, this is done. Yes, it's not a to do anymore. I'm really confused. Should also be like this. Okay. But this whole thing is really confusing. I don't know why it would emit anything to bytecode. Let's see. Expression. So in compiler, we just click here, right? Oh, because it pops something. We should just say default. We'll say break. Well, it should be compiler error. Program token is just statement token. An error is invalid. Unsupported statement type. Exclamation mark. The same for expressions. We'll just say unsupported expression type. Okay. Say expression token. Okay. Because expression statements implicitly pop something of the stack, but yeah, okay. Actually, I think when we do function calls, I think I would rather take the pref, right? So what I would do is I would say left left token like this. I think is preferable. Yeah. Unsupported expression time, yeah. Okay. That does it. Also, I feel like this is kind of stupid. The way I print. the errors. This should just say, oh, because I used log error. It's fine, I guess. Not sure. Anyways, it's not that important. Okay, but technically what we should be able to do now, if we had function support, is we should be technically able to do, say, like a and end. It says return a times 2. And we should be able to just straight up call this and say like that, like 20 equals this. Like this technically is valid syntax, according to parser at least, or should be. Expected semicolon after expression declaration. No, maybe that's not a valid thing. Actually. Because this is still... like, it has lower precedence than call, so this is technically still wrong. So to allow that is, we just need, so read, when we have read expression, right? Just need to move this whole code here, from here. We need to move it to read primary. X token up in parent, right? Say here. We'll attempt to make a function. Yeah, an interesting piece of code because it works like this. It tries to parse a function, and if there's an error, instead of reporting it, it just proceeds to just doing the default statement here. Return fine. I think it's fine to use return here. And comma, right, function, expression function, push function, expression type function. Should we also do that for identifiers? Expression type value. Oh, I don't know actually, because this might be a problem later down the line, because expression... I mean, it's probably fine if it's a function. Let's see. Do we compile this correctly now? Oh, I see. Because we already have done that. I guess the weird thing is that we push an expression here no matter what. It's kinda weird. We do that. Oh, whatever. That's fine. Yeah, now it works. See? This just means that function calls can technically be called on either values of type func or on expressions of type function. That's fine. I think that's compilable. Well, maybe this should be converted to like type. So when we have identifiers, right? have them here. Maybe this should be converted to expression type function. I don't know. Or no, this is expression type identifier. So that's fine because that just means instead of it being a literal in itself, it means it will actually just want to point to an identifier. Yeah, I think that works. Let's put that. Okay. We'll say like this and like this to stay with the convention. Or maybe no, maybe I just did this then. I restore the state. We haven't parsed the function. Okay, I think that does it. Yeah. So now functions are fully literals, so we can do insane things like this. I don't know, that's useful. But I feel like just being able to like write a scope and call it. This looks fucking insane. I guess. But this being callable just like that, it's just fine, I think. It's a feature. I mean maybe no. I don't know. We'll have to think about it, but I don't think supporting it costs me that much once I figure out how to do functions anyways. And then just like print 20, right? It's just like a function. Uvu. Yeah. I think all I need for this really is just say this. No, we don't need to have separate ones. And we'll now just say variable type. We'll think if it's actually sensible to have separate file. I don't know if it's sensible to have the same kind of. In okay, so get function type doesn't make any sense because it's already handled. Declare variable type and declare function type. This probably makes sense to be different because this one takes just more stuff, and the func type on the other hand is just function type, or rather runtime type function, right? This is all this needs to be. Declare function type, get function. Okay, yeah, that's fine. Do I have unwind type scope? I do, okay. That's great. Okay. To do. Enable the to-dos. To do. Set results type. So whatever the var is. I guess resolve resolve global scope types so they can be made bound. Whatever. It's fine. And then I guess to do all of those. So this one is actually simple because this is just expression, results type, runtime type function. Simple. Unary up results type. This is just unup type, unup type. resolver, expression, unary up, expression, and expression, unary up. That's what we need. Resolver. Okay. Same thing goes for binary up, binary up expression. Yeah, we pass 2 here because this is actually binup type. Right, okay. Should be fine. Not entirely sure how I do casting. I guess casting is just like something in compiler that I do. Like the implicit casting for function calls. Yeah, I think that's just something in compiler actually. Okay, this says result type. This just always evaluates to runtime type integer actually. What I made print return is the amount of arguments it printed. That's fine. So this needs to also set results type to the results type of function. The function. Okay, so results type is now done for all of them outside of the 2 that need type resolution to be finished. I'm not doing that today. I need to go. This is like mostly, yeah, this is done. This is not even like parsing. I guess this is like the yeah, sure. This is like resolver thing. So this is like what we'll do. I don't know. I don't know. Let me think about it. This is like in progress, anyways. And or I guess maybe this is in progress and this is something for later. Time limit rules would be nice. Whatever. Make type resolution. It's on yeah, so this is in progress. So actually didn't do, I mean I did do a lot of things today with like restructuring stuff. We were able to take some items off. But I need to go for now. Maybe I don't know. I don't think I'll stream later, but maybe I do some work later. Not sure. Wanted to do variables, but don't know. Actually, I guess I'll just spend a bit more time here so I can do type scopes. So the way we do type scopes is as following. So each scope definitely needs to have its own type scope, right? Type scope. New type scope equals make type scope resolver type scope like this, right? New type scope. I'll rewind the type scope after the resolution. Right. Declaration should say define. So this would be like declare variable type. We have something that says declare type. Do I need this? It's probably fine. Type scope. Statement token. Statement. Right. And actually for this we don't even need the token here because it's just declare. It's just the declare token. Declare type. Like this. How do I do declare again? Is constant declare? Yeah, this is just is const, right? That's fine. I think that does it for declare. I think all I'll have to do here is do all implicit casting first half when possible. So we'll know that to do type check value and I guess an identifier of type check value with identifier when needed. Otherwise, use implicit casting and compiler. Rather generate. Emit implicit casting and compiler also applies to assign argument function call args and etc. Okay. So that's something I'll have to do. And here we do new type scope like this. And we shall say if the statement scope is an implicit scope, sometimes happens. You actually don't want to make a new type scope. This is for function calls, so we don't have to create two type scopes for it. Maybe that's like overly stupid that I do that, man. I don't know. It's probably like it's probably optimizes the output code a bit too because we can We don't have to pop stuff. Although, would we ever need to? I don't know. Maybe that doesn't make a difference on the like content. So I'm not sure if it's worth it. So if this variable isn't a function, we need a resolver error, resolver expression token, and function has wrong results type connection. So I guess function call on wrong type. A result type equals var type, result type. Right, I guess we'll say runtime type function anyways, and then say if the argument expression result type isn't the param type, then we say resolver error resolver expression token and invalid param argument type, actually. Like this. We'll say the first param is parameter param equals var type parameters. Now this is actually like function params first. Guess we'll not do this evaluation if we had the resolver, because that's probably a crash, since if this variable type is if this variable type is like an integer, if this var is like an integer, then we know it's Kako. It's not actually, it doesn't actually have a function literal pointer. Okay, so here param equals param text. Okay. So if there is param, I actually had that wrong for the other functions. It was something I was thinking to fix, but I never did. Okay. And now if we say, if there's still a param, we'll say error resolver say two little arguments, and in this case we'll say too many arguments. Right. Okay. Yeah, I think that really does work, you know, right? Let's say too few arguments, actually. And now the result type is just a function, right? I know, function call... No. So if the type isn't a function, that's when we're wrong. And the result type should be the result type of that function, right? What else is here? There's function as a result time. Yeah, right. Okay, yeah, that's correct. That is correct. Maybe what I do is I say break here because this is a switch statement, and then we'll do this, right? Okay, so now we obviously don't have any execution for functions at all. If I say this, what it will just say, actually, this will say that the var type doesn't exist, right? So we'll say if no var type, we'll say function doesn't exist. Doesn't exist, right? That should do it. Function doesn't exist, but it doesn't print the token correctly, interestingly enough. Right, print lex token line resolver token. Okay, resolver. Oh no, this is a problem. We don't have the lex here. Oh, we don't have to have the lex here. Okay, never mind. Just goofy. And this is funny because I guess. So we do different things. So we actually always are supposed to use log error, let's say, because that's the convention we have. It's a weird convention, but let's stick with it. Log error resolver. Is that what we used for parser? And that's also what we used for lexer. Yeah, okay. Okay. So now when I run, we should be correctly say that, yeah, function doesn't exist. Indeed. And runtime, we don't need the new line character. Oh, what? No, actually I'm wrong. I'm just wrong. This was always a printf. That's good. Prefer it that way. Printf. So wait, on runtime. So I fit, maybe compiler is the one. Yeah, okay. Printf. Compiler error. Like this. We'll say we'll give it a new line. Then that does it. Resolver doesn't print a new line. Okay. So one sec, we'll check them one by one. This is correct. Lexer is correct. Parser is correct. Resolver is correct. Okay, runtime is correct. Okay. Okay, function doesn't exist, right? And now if I say something is a function of type A and B and, right? Should just tell me that's bad. That's bad. Attempt to assign a value of no type. Attempt to assign a value of no type. This is wrong. Should be like this. Function doesn't exist. That's false. But let me first fix that. So what do we expect? Read sign, so read expression, right? Here, right? So if we read an identifier statement, I actually this thing. Holy fuck, how do I do this? It's not even identifier of anyways, but fine, we say read a sign expression. Right, and now if parser is a bit stupid, but if the current token is token type close brace, or if it isn't, then we expect a semicolon. Expect semicolon after current type, right? So if the current, so basically if the last thing we evaluated was a close brace, we don't need a semicolon. Expect a semicolon after sign expression, I guess. And we return the expression, right? So that makes it easier, but also undoes the Oregon errors. Expression equals here, right? This also. I guess here too. Okay. We have some problems here. XD. No, we should have stopped this here, I think, right? What is this state here? Do I even use it? Oh yeah, because I... This is kind of stupid. Why would I need that? Yeah, okay. So now we go here, we go here. Oh. Yeah, it's well so I guess what I need to do is if oh yeah, because yeah, so that's just a bug in the loop. It just doesn't pop. So when we do read statement and there's no statement, we just need to pop a token. This function doesn't exist, which is not true. That probably means they have not ever declared resolve expression. Hmm. So how do we do this? So in function call, we get a variable type, and this function doesn't exist. So that probably means that in statement type declare this didn't work properly. Let's see. Okay, I think this is a function. It's correct. Okay, I don't really see a problem here. And now in function call, it says, oh. So see, the identifier name is that's actually very interesting because this is not an it doesn't have an identifier. It has an expression. So that's what we did, right? So what we have to do here. Hmm. That is very interesting. Changes this problem completely because we don't directly access. So this means that result type needs to be augmented with all the function stuff. So let's just say we first resolve this, right? Resolve expression. Oh, let's just say resolve expression. Without type, I'll say resolver expression type scope like this, right? Resolve the function expression, and now with result type, we also just need a result. So we'll have function. It's real result function, right? And this can just be actually wait. So function literal. This kind of bloats the expression size a bit, right? Function literal. It's not small. Oh no, it is pretty small because it's a runtime type. It doesn't actually have a value. So it's like 3 pointers and 1 enum. It's not the end of the word in that case. It's kind of redundant when we actually have the function literal here, but whatever. Something we can try to refactor later. And what I'll have here is also here, if the variable, if no var type, then we want to say, just say variable doesn't exist. Variable doesn't exist. Also, one thing I just remembered is function twice. No, this is actually reserver function twice, right? This should be variable here. Okay. Now result that's fine. But in the case of this expression, result function literal equals var type function. And this is actually a pointer, so that's even better because we can just do this, right? Function, okay. So now we should say, so okay, if var type variable doesn't exist, yes, and here we'll say if the result type of this expression, right? Let's call this something simpler, right? Let's just do this. And now if result type of this isn't a function, we say function colon wrong type. And we'll say function literal function equals expression result function literal, like this. Function. Just do this now. Okay. Yeah, okay. That does it, I think. Yeah. Now we only have problems in the compiler. Okay, so we fully made this good. So we don't have a global scope correctly yet. We need to do that, but make type resolution, that's done. Let's just make type pre-resolution for late binding, for global late binding. And we also made this fully work. Okay, I think that's pretty good. So this compiles to bytecode, and this is a scripting language for the game I'm working on. It's for AI opponents in in an RTS game, and it's also for triggers for that RTS game. So really important for it to be really fast, and it's really important for it to be very powerful. Because it's meant to be this thing for custom content and a very expressive AI. But yeah, I'm actually closing the stream now, so. Norsky? What is Norsky? It seems like Norsky tools, is that it? No, I don't. That's probably not it. I don't know. but yeah, it's pretty fucking good, I think. I did type checking today, so this is like a strongly typed language. It's meant to be fast. Bytecode's not as fast as machine code, but I can't compile this to machine code. I can't ship the game with LVM, nor I don't want to fucking write my own assemblers for like free operating systems. So yeah, but this is some nice practice. It's pretty cool. So yeah, I did time resolution. Yeah, we'll need to do that. Okay, yeah, that's it for me. I will commit this and I don't shake trees, but sometimes I smoke trees, so that's your kind of thing. Commit progress from stream for my 2023. Yeah, that's nice. Thanks for the follow. I'll stream tomorrow and the day after, and I just streamed daily recently, so that's it. And we'll finally do some variables tomorrow probably, although I still have to do pre-resolution of types for late bound globals. That might not be as important, really. Maybe for now I just don't have late binding and I add it back later. That's probably doable. Just having the bytecode actually execute functions and have variables is really important for this language to even be like showcaseable, right? And then I want to also add like asynchronous stuff, because big thing with this language is like RE, you mean reverse engineer? Or one? I do some reverse engineering. Did that for a Brood War mod. So CMBW. Yeah. Go Smarky. Brood War. This is the mod I was working on. So this is the official website. And this is like basically reverse engineered StarCraft made like all patched in like assembly and stuff. So yeah, that's what I usually do. And now I'm working on an engine for our full game that isn't a mod. And scripting language is what I work on right now. With that, I should be able to. So I had like this like demo thing a while ago. Where do I have it? That's probably here. Or no, actually, this is in the Antikythera thing. So AI. So this was like yearly draft of this, where like I would have async loops and I would if ones or whatever. This is basically meant to like you can like this is the syntax is completely different now, but like you should be able to like say that if something happens and I want some code to be executed, I want to wait until something, or I want to wait this amount of seconds or whatever. I want to like request some units. I want to like attack here, like make an army of those units or whatever. And that's all meant to be asynchronous, so you can do it very simply on high level, but also make it fairly fast. So like it's very meant to be very declarative, where you can declare many like interesting like basically like define the whole strategy of the computer bot, right, of the AI. And I think the asynchronous stuff has a big potential, but another thing that this language does is it's structured. It actually has like braces, it has scoping, it has variables, it has types. That's not something that we had in ISC3. ISC3 is this language that is like assembly style like, where you just have like jumps and you don't even have variables. And that's what we dealt with for CMBW. And now we'll have something actually good. You'd take more functional? You mean like actually like closures and stuff like that? Or how would it look like? Closures, yeah. I don't know, because we are not used to functional programming. But that could be interesting. I don't think I will support closures in this because they are pretty slow with like all the heap allocation, but I have considered them and I'm still considering them as oh, you just mean that it's like harder to do bugs in the language? I'm trying to make this very I want to make this very like safe to write and also not like I don't want this to be like JavaScript or Python where it can just randomly like throw you an exception and kill the AI. So I'm very wary of that. I think I can do something decent. So yeah, I'll be working on that tomorrow and the next day and the next day. And I'll see you then if you want to come.